Good evening, everybody. I just accidentally clicked the wrong thing for a moment, so hopefully you don't see the wrong thing. Hopefully you see me. Good evening, and welcome to Math and Chill. I think this is 26. I'm almost positive this is Math and Chill 26. Friday night, mathin' and chillin'. What are y'all doing here on a Friday night? Don't you have better stuff to do? The answer to that is that for most of you, it's probably not a Friday night because you're probably in a different time zone. So we're gonna hang out, do some math maybe, work on some math raps. We'll see. Always open to suggestions. If you guys have any, whatever you want to see, if you got questions, comments, or if you have any math rap requests, I'm always happy to hear those too. Ash says 6:30 a.m. right now in my location. Good morning. Thanks for coming by the stream, Ash. Good to see you here. And a good morning to you. It is 9:45 at night for me, so it's not morning, but hopefully it will be a good morning soon. DNDBD I'm not sure if there's any way for me to pronounce that other than reading the letters. Says Dogecoin to the moon. I don't know why someone in chat is here talking about Dogecoin, but yeah, Dogecoin to the moon. There'll be a lot of happy people if Dogecoin goes to the moon. Thanks for coming by the stream. I'm happy to see not Filecoin, well, Filecoin too, but Litecoin. Litecoin had a huge day today. Over 300, right? Litecoin's at like 320 right now or something, but this isn't a crypto channel, so again, thanks guys for coming tonight. We'll get things started here in just a minute. As always, let me know if you have any questions or comments, if you'd like to see me perform any of my math raps that I've already released, or if always happy to see what you have to say. So I'm going to take the inaugural sip here of Sleepy Time tea, and we'll get things started. Whew. And as always, let me know if any of the audio is off. If anything's too loud or too quiet, let me know. Joshua Bowden says, "Hey Sean, did I spell it right?" Yes, you did. Happy to drop in again. Nice to see you, Josh. Thanks for coming. And yes, you got my name right. So that is my name for any of the uninitiated. I, Wrath of Math, also go by the name Sean, S-E-A-N, of the many ways to spell it. So I'll tell you here, if you want some amusement as we begin the show, the little rhyme that kids used to bully me with when I was really young, like I really wasn't bullied much, just a little bit, like when I was really young, where probably everybody was getting bullied. The rhyme kids used to say to me was, Sean the leprechaun went to school with nothing on, asked the teacher what to wear, polka-dotted underwear. That was the rhyme that was used to belittle me. I think, and what's funny about it, I think there's two things that are mocking about the rhyme. You know, the first thing is that I should be consulting the teacher about what to wear, which kind of paints me as a teacher's pet. And the second thing, of course, that is mocking me is me wearing polka-dotted underpants. That's also, what's worse, tighty-whities or polka-dotted underpants? I feel like polka-dotted underpants has to be worse than tighty-whities. Joshua Bowden says, based on a true story? No, not based on a true story. Although, if I was going to school in polka-dotted underwear, whether or not I'd ask the teacher about it, if I was, and again, any new folks coming into the stream, thanks for coming. This is Math and Chill, currently talking about my underpants when I was in kindergarten. If I was wearing polka-dotted underwear, the kids could have known, because there was a moment where I was in the bathroom at kindergarten, which was just like a single room in the classroom, and one of my classmates, for some reason, decided that he was gonna barge in. So like he was knocking, and eventually he just kicked in the door, and there I was in the bathroom, and they had kicked open the door. So that was kind of embarrassing. I don't remember what state I was in, like if I was, on the John or what was going on, but it certainly wasn't pleasant. It couldn't have been too bad, though. Otherwise, I would have remembered, right? All I remember are the vague details. But you guys probably aren't here for me to talk about my childhood trauma. Frederick Stormo, good to see you here in the stream, Frederick, says, Hey Sean, do you have a favorite branch of math you're most interested in? Oh, this feels so personal for people to be using my name. It's nice to see. Um, yeah, I don't know. It's tough to say my favorite branch of math. I study a lot of probability, and I like probability a lot, probability theory. Although a lot of the time I spend with probability isn't it's not the type of stuff you might be studying if you were to say take a first course in probability theory and then take a second course in probability theory. A lot of the probability theory that I study is in the specific context of actuarial stuff. So I like probability, but it's probably not my favorite. I like graph theory a lot. I like real analysis. I don't think I have a favorite. I really just like geometry. I could say is not my favorite. So I like geometry, and I'm trying to get better at geometry recently, but me and geometry have a complicated relationship. But, I'm trying to get in better shape with my geometry skills. Scientific Irfan sends the smiley angel emoji. I'm glad to see that you are in holy spirits this evening, Scientific Irfan. Thanks for coming by the show. And Joshua says, at a glance, you give off a category theorist vibe. That's probably a good vibe to give off, but no, I don't know a lick of category theory, really. So I definitely look forward to studying category theory, when the time comes. But I got my bachelor's degree, and I got out of university as quick as I could. I didn't want to be there, and so now I just, I study math in my free time, and I'm doing it independently, which is what I prefer. Axel Garandato, thanks for coming by the stream. Axel says, you are indeed great explaining concepts in graph theory. Thank you. It is my pleasure. I love, I just love explaining and talking about math, so I'm super glad that you found the graph theory lessons helpful, Axel. And is it Axel or Axel? I'm not sure, but I'm glad you found the lessons helpful. There's more graph theory coming. Recently, I started making a couple graph theory lessons, and I'm like, I've got like 140 videos in the graph theory playlist, so I really want to, keep hacking away at it. So I'm excited to get some more graph theory out. Xin Zhao says, hey Sean, what do you think of the mathematics used in mathematical physics and theoretical physics? Well, I don't know much about physics. As far as like schooling goes, I took a high school class in physics, which was a total joke. But I think, one of the common facts you hear, like when people talk about the ridiculousness of the sum of the natural numbers being -1/12, which most of you are probably familiar with, maybe not, but probably most of you are, is that even though it's crazy, it has some significance because it's used in, I think, string theory is what they say. And that's kind of a meaningless thing for me to say, and I think it's meaningless for most of the people who say it. They say, oh, this is used in string theory, but don't have the slightest clue how it's used. But I mean, I always think it's super great, the way that mathematics is used in any real-world applications. It's just so great to see mathematics reflect reality. And although I'm perfectly content, and I frankly prefer to just stay in abstraction, like I'm not yearning for applications of the math that I study. I'm totally happy to just stay in abstraction. I am, it's exciting to see mathematics applied in the real world, and sometimes a real world example here and there for me can be pretty cool. And so in physics and in finance, where we see calculus just absolutely, calculus is just so incredibly useful. It's just shocking. I think it's super cool. Calculus is great. It took me a long time to appreciate calculus. Joshua Bowden says, graph theory has nice connections to category theory. You'll probably like it. Yeah, in the glances that I've looked at category theory, it definitely looks up my alley. So I'm excited, but it'll be a ways off. There's plenty of stuff I want to study first. A lot of my studies these days, when I'm not studying like finance, probability stuff, is just brushing up on stuff I studied in college, kind of going through it again at my own pace. Shin Zhao says, I'm studying math on my own as well while working a factory job, along with physics. That's awesome. Yeah, so I'm doing the same sort of thing, working a job which has me. In my job, we have to spend a lot of time studying some mathematical stuff. So it's pretty mentally exhausting to be doing that and then also studying more math afterwards. But it's like, I don't know what else I'm going to do, It's tiring, but it's just what I like to do, so. Scientific Fan says, your explanation is often easy and funny. I enjoy watching your videos. Glad to hear that, Scientific Fan. I appreciate the kind words, and I'm super glad that you find the explanations effective. I really try my best, and when I finish a lesson that I think I did a good job explaining, I'm really happy. It puts me in a good mood. So I'm always glad to hear they've been helpful. Again, any new folks coming in the stream, this is Math and Chill, talking about math, chilling. Gonna start working on some math raps here pretty soon, and fielding your questions and comments. If you want to help support the show, if you want to see more live streams and just help me run this channel, you can consider hitting that super chat button, or you can send in a small donation with a big message that'll appear all colorful. You just got to hit that big $sign if you want to send in a small donation. There are also donation links in the description if you're interested. Axel Gandato says, can you give an advice on how to be good in proving for beginners? So when did I start studying proofs? I guess that would have been my freshman year of college, second semester, which would have been the spring of 2016. So 5 years ago now. 5 years ago is when I started studying proofs in college. Advice for being good at proofs. Well, definitely you want to do a lot of them. You want to see a lot of them. It helps to be excited by proofs, right? So for some people, proofs are really boring. If you're studying math, particularly if you're going for a mathematics degree, hopefully you like proofs, and it's exciting for you to see truth in absolute purity and abstraction certified beyond all doubt. Not beyond reasonable doubt, but beyond all doubt. So hopefully you appreciate proofs. If you do, that's going to make it a lot easier to get into it, because even if you're struggling, you're going to be like, man, this is so cool, I would say set theory. You want to be working with set theory. So most proofs, I think most of the time when you get started on proofs, it's going to be with sets, excluding geometry, right, back in high school. But once you're in college, when you get started with proofs, it's usually presented with sets. But if that's not how things are going for you, then I would definitely advise you to look at some set theory proofs and prove some basic set theory stuff, because set theory proofs, you could go through a giant list of basic set theory proofs from like a first chapter of like practically any math textbook, because they all start with set theory. And you could just do direct proof after direct proof that flows really nicely, applying definition after definition. Not only that, but these basic set theory proofs are so straightforward that it's pretty easy to kind of tackle it in whatever way you want. So for a lot of them, you can say, okay, I'm going to do this as a direct proof. Now I'm going to do it by contradiction. Now I'm going to do it by contrapositive. Now I'm going to do a proof by minimum counterexample. I haven't actually really seen those with set theory, but so do lots of proofs, which is always kind of obvious advice. Do it a lot, and you'll get better at it. Focus on those set theory definitions. Book of Proof by Richard Hammock. That would be my recommendation if you want a nice book on proofs. Richard Hammock, I'm putting it in chat. Book of Proof. You can look it up and get it for free online, but it also has a really nice physical edition. Besides that, I think look at proofs about math you're interested in, right? So there's one other thing I would say. I could talk about this forever, so I'll stop it there. But look at proofs of math you're interested in. If you think about something, I'd like to know why that's true. Check out a proof. One of the number one things I think you can do to be succeeding at something is to make sure you're enjoying it. And a way to do that, of course, is to look at some proofs of math that you're interested in. Let's see. Xin Zhao says, I'm trying to remember integral techniques from Calculus 2, but I can never remember them as well as the rules of derivatives. Any tips? No, I suffer from the same affliction, Xin Zhao. I've totally forgotten like all the complicated stuff from Calculus 2. That's definitely in my list of stuff I need to review. So my tip to you would be to not get too worried about forgetting things, like it's gonna happen. We all forget the stuff. If you're in a situation where you have to, you have to use this stuff that you've forgotten, then obviously that becomes a little bit of a problem. And I mean, if I were in that situation, I would crack open a textbook, look at some examples. I might look at some videos if I need to. Examples. I think examples are a good way to just say, oh yeah, okay, I remember that. Examples are a quick way to jog your memory. But yeah, I forgot like all of Calculus 2 as well. When I tutored math in college, there was this girl who would come into the tutoring center for math help, and she was in Calculus 2, and she was very smart. And she was always basically just taking me along for the ride. It's like, yeah, I got no idea. I've forgotten what you're doing. And she kind of shows me, and maybe I'm able to look it over and catch a mistake here or there, but it's like the process she's going through. I'm like, I don't know, man. I haven't seen this stuff in a year, and I've already forgotten it. Calc 2 and Calc 3 for me in college were tough. I got A's in both of them, but they were not easy. They were not easy A's. So I know that's not a super helpful response, just I feel your pain. Joshua Bowden says, another thing is, too, when you can, always try the proof to some extent before seeing the solution. Yeah, that's good advice. Just in general, good math advice is to try stuff before seeing the solution. Even if, you're in a rush and you really don't want to try, give it a think, right? If you really don't want to give it a firm try and write anything down, just give it a think, right? Think for a little bit. How would I attempt this? How might I prove this? Or even, instead of that, you can read the first line or two of a proof in a textbook, right? So a textbook will often say, here's the theorem, now we're going to prove it. Read the first line or two of the proof to get an idea of where it's going and try to prove it from there. If you do that, that's just another way of getting extra practice, and it helps prevent you from getting too passive in your consumption of proofs, right? Because you're not going to get good at proofs by just reading a bunch of proofs. That will help for sure, especially when you're just starting to see a bunch of proofs. But you definitely want to be doing them. You don't want to stay too passive, which is always something to keep in mind for math. And one other tip on that note is what was I going to say? Don't stay too passive. You read the exercise, read the first couple sentences, try the proof. I forgot what I was going to say. It was a good tip too. I think it was a good tip, but I forgot. If you do a proof or if you read a proof, I think it's often valuable to take a moment to zoom out a little bit and try to identify the more abstract strategy that they took. So it's a type of thing that's a little more narrow than a proof technique. So it's not, did they use induction or did they use contradiction, but it's not as specific as the actual proof. It's a more, I'd have to, look at some specific proofs, I guess, oftentimes this will be specific to a particular area of math. So it might be particular here's a common technique I see in a lot of these graph theory proofs. Oftentimes, if we take a longest path in the graph, we get some useful information from that. So, that's a technique I'll put in my tool belt. Next time I'm struggling with a proof, maybe I'll try taking a longest path. And, you can see these recurring themes in proofs of a particular area of math that you find are often helpful. Like in real analysis, we see the triangle inequality theorem come up a lot. It's like, I got this expression. I don't have any addition in this absolute value expression, but maybe we could use the triangle inequality theorem if we subtract and add something useful. and maybe we'll try that. And so yeah, be on the lookout for recurring themes in the field of, whatever you're studying with proofs, and that can often be helpful, just to spend more time thinking about the proofs, and so that you can get some tools that might be useful in the future. Manesh Patel, good to see you here. Mahesh, I said Manesh at first. Mahesh, good to see you. Says, calculus is hard, but also beautiful and satisfying when you will solve by yourself. Just watch examples, solve, and try different stuff. Yeah, I agree. Calculus is hard, and it is beautiful. Like I said, it took me several years to really appreciate calculus. I never really appreciated it in college. I appreciated it long after. I appreciated it once I saw it so much in probability, and once I studied it a little bit more generally. Once I got out of the weeds of calculus a little bit and just read more about it, I really started to appreciate it. Again, to any new folks coming in the stream, this is Math and Chill. Thanks for coming. Hit the like button if you're enjoying the show. Just doing some more blabbing here than usual. Always good to see you. Let me know if you want me to shut up and start rapping, and we can shift right over to that. I don't want to bore anybody, but always good to have you guys here. I hope you're all doing well tonight, and a new episode of Coffee Time Math came out today, this morning at midnight my time. I hope you'll check it out if you haven't already, but don't check it out now. Keep hanging out with me, but after the stream you can go check it out. It is a little repeating decimal diffraction problem. And even if you're not super into that particular problem, for some of you, maybe it's super easy if you've seen that sort of thing before, but it's a fun little trick. But I filmed it in an interesting location. I filmed the math video that came out. So it's at an abandoned 1800s mill town where I filmed this math video. Their mill burned down 3 times, and there were 2 grisly murders in this town that nobody was ever prosecuted for. 2 grisly murders. Both of those interesting details I don't mention at all in the math video. I just say, hey, I'm here in this interesting place, but I'm not going to tell you anything about it because we're here for the math. But kind of cool. Shin Zhao says it's all good. Appreciate the answer. Glad to hear it. Mahesh says, especially proofs in number theory and arithmetic is very beautiful. Yeah, I never took a number theory course in college, but I've spent a bit of time with a number theory textbook by George Andrews, although I haven't picked it up in a while. But those proofs are cool, and some of them I find pretty tough, because a lot of the number theory proofs I see have like lots of indices. There are a lot of indices, which can be tough to keep track of. Fun fact, I was at George Andrews' 80th birthday math conference at Penn State University. I was there, which is pretty cool. Joshua Bowden says, Shin Zhao, because integration is undoing differentiation. It might help thinking about the techniques in terms of how they undo differentiation, i.e. U substitution is a reversal of the chain rule. Yeah. Good advice. And Shin Zhao says, thanks. Mahesh says, like proof that prime numbers are infinite. The proof that primes are infinite is one of the most elegant and just fantastic things in the world. It's just so beautiful. I've read it enough times now that like when I see it in a book, I skip it. But for a while, I didn't skip it. It's just like, man, it's crazy every time I see it. I think the first time I read the proof that there are infinitely many primes, it was in The Magic of Math by Arthur Benjamin. I read the proof. It was like 2 sentences. And I was like, whoa, that's crazy. The proof that there are infinitely many primes. It's so slick. Just a wonderful proof. I don't know why I never saw that proof in my proofs class, but I'm pretty sure I didn't, which is really weird. Really weird. So, thank you guys for all the chatter. Always nice to talk with you. Let's see here. Let's do something stupid here for just a minute. Do I want to do something stupid? Well, let's do a little bit of the rapping first, and maybe I'll do something stupid after. So here's the rap that I've been working on. It's a rap of a proof of the Pythagorean theorem, and it's almost done. We almost finished it during the last Math and Chill live stream. Been streaming a couple times a week recently, so if you're not subscribed, make sure you hit that subscribe button so you don't miss them. Hit the notification bell. If you hit the notification bell, then I think that will notify you of the live streams. But keep your eyes peeled, because I'm going to keep streaming pretty regularly. Nathan Weaver, that's the name of my best friend. Nathan Weaver says, do you think a student should take a linear algebra course before an abstract algebra one, or would it not matter much if taking both? If taking both at the same time, is that what you mean? You always have to be careful with the multiple math classes, right? Because it's tough. Multiple math classes is tough, but I think, if you're a solid, confident, mature mathematician, in like your third, fourth year of college, then, you're probably good with like 2, 3, maybe even 4 math classes. But, that's kind of just a ton of work. 3 math classes. I think the Math Sorcerer says 3 is like the most he could do. So I'm going to say 3 is probably a good number. I don't remember what the most I ever did was. It was probably 3. Linear algebra is another one of those subjects that I'm super, super rusty on. Like I, passed the class, got an A, and then forgot everything. And I think I took abstract algebra after linear algebra, and I didn't have any trouble. But I think abstract algebra will make use of some matrix stuff for examples of algebraic structures. So if I had to give a recommendation, I would probably say linear algebra before abstract algebra. But I don't think it's a huge deal. Even if you haven't taken linear algebra, you've probably seen matrix operations before. So I don't think it matters too much. Xin Zhao says, how can you get started with proofs and learning how to make proofs? Well, I would say that book that I sent the title and author of earlier, Richard Hammack, Book of Proof. Pick up that book and you'll have a nice guy talking you through the process, talking you through getting started with proofs. That's really it. If you just want to get started, you will have the power to, read the first chapter of that book and you will be able to do some of the exercises. You'll just have a super straightforward, prove this is a subset of this. And as long as you know your definition, prove A is a subset of B, you'll say, okay, I'm going to take an element of A, I'm going to show that it's in B, bam, you're done. So if you want that satisfaction of getting into proofs and actually writing some good proofs, Richard Hammack, Book of Proof, look it up, free book, PDF, you can get it for free, and read through that bad boy. Introduces you to all the different types of proofs. It's tells you about set theory, which you really got to know when you're starting to get into formal mathematics. It's really like, a set theory book with a proof theme, as far as I remember it. And it's got a lot of good stuff in there. So it even touches, I think near the end of the book, you even get some real analysis type proofs too. So I would start there. Joshua Bowden says, to quote Dr. Payam, you can never know too much linear algebra. I've never heard that Dr. Payam quote, but it sounds right. I agree. I'm not big into linear algebra, but I agree. You can never know too much of any math stuff. Xin Zhao says, I took linear algebra. I feel the same way. Got an A, but forget everything. Yeah. I think, let's see, on my linear algebra final, I wrote a note to my professor to tell her husband to give me an A in Calc 3. Because my linear algebra professor was married to my Calc 3 professor. So on my final, I was like, please tell Dr. Wright to give me an A in Calc 3, please. I did manage to get an A in both classes. I got an A in every class, except for just one. There was just one weird class I didn't get an A in, which was a bummer. Xin Zhao says, does the proof of book? It's not proof of book, it's book of proof. You commuted the words there. The book of proof prepare you for the proof techniques needed for real analysis. Yeah, roughly speaking, it does. It introduces you to your basic proof techniques, and like I said, which you may have sent your message before you heard what I said because of the sort of time lag in the stream. But it does have some real analysis proofs in it. I don't even need these headphones on right now because, I'm not listening to an instrumental to rap over. And now I feel so exposed with my headphones off. I'm just going to grab the book of proof. I have it in my bookshelf. I'm just going to grab it real quick. Here it is. So you can get it for free as a PDF, but it does have this beautiful physical edition. And it's a nice hardcover. And look at the size of the font in this bad boy. Look how big that font is, man. It's a beautiful, beautiful book. So not only does this go over your proof techniques, but yeah, it has some real analysis proofs in it. We've got sets, logic, counting, direct proof, contrapositive proof, proof by contradiction, proving non-conditional statements, so statements that aren't of the form if P then Q. It's got proofs involving sets, it's got disproof, it's got induction, and then it's got the final section is where you're getting into your real analysis stuff. So the final section is, you can't really see it, but you've got relations, functions, and then proofs in calculus is one of the final chapters. Has definition of a limit, continuity and derivatives, sequences and series. So I mean, this is a bad book in the best way. You know what I mean by bad book? It's a great book. Let's see. Nathan Weaver says, we used Book of Proof for my set theory class. It was really good. Yeah. So Nathan Weaver gives his approval, and if it's good enough for Nathan, it's good enough for you. That's what I always say. I've been thinking, you guys can tell me if you have any opinions on this. I've been thinking of making just some short videos telling like stories from my time in college or time in high school, just sort of from my experience, learning math. I don't know if you guys would be interested to have some videos like telling a fun story for a few minutes. Like, the story that came to me last night is the story about how my calculus teacher called the police on me before we ever met. That's kind of a fun story. Joshua Bowden says, I feel like you're really itching to get to some rapping. Well, not necessarily. I'm super happy to sit here and chat with everybody. But I'm like, oh, can I possibly be that interesting by just talking, Am I that interesting just talking? Should I just ignore you all and start rapping? I didn't title this Math Rapping. I just titled it Math and Chill. So I'm not obligated to rap. As I say, I'm open to just blabbing if that's what you guys want to do. Right now, you guys are saying lots of stuff, asking questions, so I'm enjoying the blabbing. But we'll get to some rapping here. Shin Zhao says, thanks for the book review. Appreciate it. My pleasure. I'm always glad to sing the praises of a math book I like because, like I said, I learn math independently. I study independently, and a vital part of that is good math books. Right now, I'm just... I meant to do this earlier. I'm just going to share a link to the live stream on Twitter. So I'm just staring at my computer here for a second. And if you're curious about a good real analysis book, by the way, Real Analysis by Jay Cummings gets my strongest recommendation. Friday night, Math and Chill. Just posting this on Twitter here. #math. Real Analysis by Jay Cummings is a very good book. It's a lot of the structure of my Real Analysis playlist is basically a combination of Real Analysis by Jay Cummings and Understanding Analysis by Stephen Abbott and a first course in Real Analysis by Kosmala. Those are kind of the three books I'm using. Joshua Bowden says, anyone's interesting enough if they are passionate about what they talk about. You're doing great. Thank you, Joshua. I appreciate your positive feedback, your kind words, your motivation. All right. So yeah, let me spit what we have so far of the Pythagorean theorem proof rap, And I think there's just a couple lines left that I need to write in this rap, and maybe we can finish it real quick here. Already 10:20. So let me spit this rap for you. Ooh, I have to remember to unmute my desktop audio so that you can hear it, and mute my background music. Here we go. Gonna spit these bars. Hopefully I haven't already lost my voice. Alright, tell me if any of the audio levels are off. This is what I'm a rapper, not a mathematician, right? Yo. From your teachers, many times before, watch them scribble and write triangles all over the board. They say a squared plus b squared is the square of c, but they haven't justified why they declared it to be. So leave it to me, yo, I'll prove it to you fast. Do it like Pythagoras, I'll be moving in the past. Four right triangles assembled in the square, alternating leg lengths on the sides in pairs. Be aware the length of each side is a plus b, so the square's area is a square by that c. But speaking of c is the hypotenuse of these right triangles that we plotted on the spot to use. We've got four congruent sides, a problem gets entangled, the adjacent sides meet at 90-degree angles. It's a square, area c squared, we're now informed why. What's the area of the triangles this guy is formed by? They got legs at A and B that meet at 90 with exactitude, so A can be the base and B can be the altitude. The area is half AB, easy with no attitude. Got four of these, that's 2AB. We frame a square to set the mood. The biggest square's area has two identities, whatever it prepared to be. The square of A and B or 2 of A and B plus the square of C expands and boils. Left side foils a squared plus b squared plus AB in a pair. On the right, 2AB plus C in the square with 2 in the superscript. Bloody 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 blah. I really like this rap, you know? I think every time I go away from it for a couple days and come back, I'm like, it's better than I remember it being. I think my hope was for this to be a shorts rap, you know, so it was going to be less than a minute, but clearly that's not going to work because we're already at like a minute and a half, so. Oh well. Man, that kind of stinks because it's like, you know, I hope you guys will share this rap because YouTube doesn't show it to anybody unless it's a shorts video, which stinks, man, but what are you going to do? Let's see. Alejandro RZ says, why is it that graph theory is so interesting? And hola to you, Alejandro. Spanish is the only language that I have any capacity to speak other than English, and I am not very good at Spanish. Anytime Spanish comes to mind, like, you know, I don't remember much Spanish that I studied. I remember perritos calientes, which is hot dogs. Or at least that's what I was told in class. One thing I remembered from my Spanish class that I couldn't believe, I realized after studying Spanish for 4 years, was that I never learned anything about describing math in Spanish, right? I learned numbers in Spanish. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, setente, ochente, I don't remember. But I didn't learn plus, minus, divides, integrals, derivatives. I didn't learn any Spanish math language. I don't know if I even remember how to say fork. I think it starts with C, it has an R in it, and a CH. How do you say spoon in Spanish? I don't remember. I know chicken, pollo. Anyways. Tempest says, spitting hot fire. Thank you, Tempest. I used to work with a girl named Tempest. I was her lead, her boss, and she was quite the interesting character, I must say. But I love the name Tempest. It's such a powerful name, Tempest. Xin Zhao says, nice, I love the performance. Thank you. Glad you liked it. I liked it too. It's a lot of fun. Alexander Sanchez says, maybe add a refrain since it's already kind of long. Nice to see you here, all three of you, Tempest, Alexander, and Alejandro, who I just saw here. Maybe add a refrain. I don't want to add a refrain because there's no need. The thing is, there's no need for a chorus, I don't think, in this sort of rap. We could put one in, you know, like every time, have a chorus where we're just like, hey, Pythagorean theorem, I rap these bars and you hear them. If you step to me, you best steer clear because I'm a dope MC. But I don't want to do that. I want to keep it on a linear track, as linear as possible. It's just proof. There's your proof. Plus audience retention, right? I want my audience retention to be a high percentage. And if I add in a chorus, that's probably going to negatively affect audience retention. Whereas just going through the proof is going to be better for audience retention. I don't worry about this sort of stuff with like my normal math lessons. I try to not make those overly long, right? But I'm not super worried about the YouTube analytics. I'm just trying to make the best lesson because that's what I think will be best. But for the raps, I put a little more thought into the, what's the YouTube algorithm gonna like? Because YouTube's a little bit more quick to share my rap videos. And like people like choruses and stuff, but yeah, I try to keep these raps short. Shin Zhao says, I studied Japanese in university and I forgot some of the grammar rules, so you are in good company. Studying Japanese, that's cool. I think, I have a ton of respect for people who speak other languages. I don't put myself in that category, because I can't really speak Spanish, even though I studied it for 4 years. Which makes me realize my Spanish class, they were not good Spanish classes. I liked the teacher. She was nice. But for it to be a good Spanish class, we should have been speaking Spanish constantly. We should have only spoke Spanish. And every now and again, she'd say, okay, starting today, class, we're only going to speak Spanish. We're not speaking English anymore in Spanish class. But that never really happened. So, all the people that are in my comments, who are, like half my age and they're speaking English as a second or third language, it's amazing. So, I have a ton of respect for people who are learning these other languages. It's tough. Learning another language, not easy, man. Alejandro RZ says spoon, cuchara. Of course it's cuchara. I didn't read you told me what fork was too. I didn't read it. Because I feel like man, what the heck do you call fork? See, I knew that spoon had a C and a CH, or no, I think I said that about fork. So maybe I got them mixed up. I don't remember how to say fork. How do you say fork? Tenedor. See, I actually didn't remember that at all. Tenedor, spoon and fork. Cuchara. I remember how to say dinner, right? Do I remember how to say dinner? Comida? La comida, I think that might just be food, but it might be dinner. You guys don't care about my Spanish. Alejandro RZ says, and math vocabulary in Spanish is very similar to English vocabulary since both come from Latin and Greek. Yeah, that makes sense. Derivada for derivative, integral for integral. Cool. Maybe that's why we didn't learn it then, because it kind of would have been boring in that way. And Shin Zhao says, I studied Korean independently, and it's the same story of forgetting stuff. Yeah, I mean, with something as complicated, as like calculus or languages, it's like, how are you going to remember it if you're not actively using it? And the answer is, you won't. But hopefully you can brush up on it a little more quickly once you've learned it the first time. So this Pythagorean theorem rap, it's almost done, right? Maybe we'll finish it tonight, maybe not. I'm already kind of losing my voice. But it's not going to be the next math song that comes out. Because in the shadows, I've been working on this Pythagorean theorem rap. Just the other day, or actually earlier today, I finished a totally different math song, which isn't a math rap. It's just a math song. I finished the audio, right? So I still have to make the video, which I'm hoping to make this weekend. But I finished the song part, the audio part, and I really like it. I like it more than I expected to. It's a little bit different. So I could give you guys a sneak peek of that if you're interested, if you want a sneak peek. I might be willing to give you a sneak peek. I'm not sure, but if you want a sneak peek, let me know. I might give you a sneak peek tonight. Xin Zhao says, positive vibes are strong with you. You are very engaging with us. Much appreciated. I appreciate that, Xin Zhao. Always try to, it's great to be able to engage with you guys. I mean, that's, it's the best part of doing math online, is being able to help people all over and be able to interact with you all, with other people who are studying math and into math. And I enjoy that a lot. So these live streams are a very positive part of my day. Actually, I'm kind of stressed tonight, which is part of why I was like, I gotta go live, puts me in a good mood. And so glad to, glad that you're enjoying the show. Alejandro says, the only words you need to know, wrath of math equals la ira de las matemáticas. Okay, I'll remember that. Ira. I never knew the word ira in Spanish. La ira de las matemáticas. I've got it. I'll remember that. It doesn't have as good of a ring to it in Spanish, does it? I remember somebody commenting saying, wrath of math doesn't rhyme in the UK or something because we pronounce it wrath, not wrath. And I told him, and I thought this was super funny, I told him, well, maybe I'll start a cooking channel, I'll start a cooking channel where, I make soups, and I'll call it Wrath of Broth. That would be cool. Zolisa, thanks for coming by the stream, Zolisa, says, what books made you understand graph theory? One book made me understand graph theory, which is a first course in graph theory by Gary Chartrand and Ping Zhang. This isn't actually, you know what? So this is the book where I really learned a lot of graph theory from. This is the book that the structure of my graph theory playlist is mostly based on. A lot of the exercises I've done are from this book. But I learned graph theory. The first time I learned graph theory was while doing research in graph and game theory. So I have a published math paper, which I've been hesitant to share. I don't really want to share that. I'm sketched out about sharing it because if I shared the paper, then you would have my last name, and I'm not sure what you can find on the internet if you have my first and last name. But it kind of sketches me out. So I haven't shared my math paper with my audience. So yeah, I first learned graph theory just kind of by being around people who were studying it, because we were all studying the same thing. We were doing research in this sort of combination of game and graph theory. Anyways, so yeah, I just kind of learned it through exposure. But as far as books go, this is the guy. I have some talks too that I've been thinking I could share. Maybe you guys would be interested in. A couple talks that I gave on math, on my research. One of them was at the JMM, the biggest math conference in the world, a couple years ago, the Joint Mathematics Meeting. I gave a talk there. So I've kind of been tempted to share those on the channel because I think that'd be cool. But, I didn't film them with good equipment. It's just, a tablet recording and I'm not mic'd up. So it wouldn't be high quality. So I don't know, I don't know what to do about that. But as far as books go, anyways, for that long-winded answer, which was just me humble bragging, I think, for 10 minutes, Graph Theory by Chartrand and Zhang, really good book. And it's thorough, it covers a lot, it's cheap, and it has lots of interjections of history, at the end of sections, it'll tell you about some of the mathematicians that were mentioned in the chapter, and so it's really good. Odiwan Kanodi, thanks. I skipped. Xin Zhao says, I'm thinking about making a math physics YouTube channel about my journey in learning both subjects. That's interesting. Is that so Xin Zhao, that wouldn't be an education channel? You're thinking more of maybe a less rigorous approach, right? Kind of a more story-focused channel, and hey, here's this interesting piece of math or physics I learned, or here's a part of my experience learning. I think something like that could be cool. I definitely think YouTube channels that have more of a personal touch, they definitely have some advantages over a channel like mine, which is largely not personal, right? For a lot of you that are, coming to the streams and watching my videos regularly, it is a personal channel, somewhat personal, because you get to interact with me on the live streams, and you see the videos where I'm being more of a personality, in my raps and stuff. But for a lot of people, there's no face attached to this channel, right? It's just a voice over a bunch of graph theory lectures that they've watched. So I think a channel with a more personal focus, that can definitely be a cool thing. That would be an interesting thing. So yeah, I say give it a try if you're thinking about doing it, making videos. For me, it's fun. I like making videos. A lot of people seem to like making videos. Odiwan Kanodi says, greetings. Greetings to you, Odiwan Kanodi. Thanks for coming by the stream. Good to see you here. Eric Lampe, thanks for coming by. Eric says, Dies Irae. I'm not sure what that means. Something about that phrase looks familiar. Maybe it's the word dies. I know that word. But I'm not sure what that means. Federico Schmidt says, can you explain to me why there are infinitely many primes? Greetings from Argentina. Greetings back from the great state of Connecticut. Yeah, so for the explanation of why there are infinitely many primes, I will explain that to you in just a minute, which is super cool. But I'm going to send you a link also for shameless self-promotion to my video that I made about it. I have a couple videos about it, but there's one video in particular that's better than the others. So I'm just going to put a link to that in chat. This is in my Math Bits series that I plan on making more videos in this series, but they take a lot of work. But I think they're pretty cool. So I just shared a link to it. Also, fun fact, I don't know if all of you have seen the first math rap I ever did, but it was a proof that there are infinitely many primes. That was my first math rap on the channel, which was last winter, I think, 2019 winter, not this just past winter. As for why there are infinitely many primes, I think I can explain it just with my voice. Rather than trying to get set up with writing stuff down. Suppose for the sake of contradiction that there are not infinitely many primes. So that would mean there are finitely many primes. And we could write them in a list. Say we call each prime P1, P2, P3, up through Pn, right? We've got this finite list of all the primes. Because there are only finitely many of them, we're supposing for contradiction. So then consider the number P. Consider this number P, which is equal to the product of all the previous primes plus 1. We add 1, right? Now that new number, P, can't be divisible by any of the previous prime numbers. Because if we divide it by any of the prime numbers, we get a remainder of 1. Right? We've got that remainder of 1 because it by definition is a multiple of all of the prime numbers plus 1. So it's not divisible by any of the primes in our finite list. But every number either has to be prime or can be factored into primes. So our number P, if it can't be factored into primes, then it must be prime itself, which would mean that we were wrong, and it was a contradiction all along, that our list wasn't actually complete, because we just created this new number that would have to be prime as well. So I think that was a somewhat sloppy explanation here with just my voice, but let me know if that didn't make sense. Hopefully it made sense. If it didn't make sense, check out that video I sent a link to. I think it's a good video. Let's see here. Zolisa says, LOL, thanks for sharing. I totally understand about sharing your paper. I'm doing a graph theory course, and I recently found your channel. Thank you so much for everything you do. My pleasure, Zolisa. Jolisa, I'm glad you understand my hesitancy to share my paper. You know, I want to brag, right? I want to say, hey, go look at my paper. But honestly, it's not a fun paper. This paper is long. It's long and it's dull. So all the better that I don't share it. But good luck in your graph theory course. I'm glad you found the channel, and let me know if you ever have any questions about any graph theory topics. Just the other day, somebody asked for a specific graph theory lesson, and I got it done in less than 24 hours. And I used to do that somewhat often, turn around viewer requests in less than a day. I don't get to do that as much anymore, but it's always super cool when I can. So always let me know if you got any requests. Even if I don't get it done super quickly, I do always add it to a list. So, you know, one day I'll get to it. And I'll come back to your comment 10 years later and say, hey, here it is. I finally did it. Xin Zhao says, yes, anything I discover that is interesting, I would talk about it. Like the basic equations of kinematics and how it is built on the YouTube channel I'm thinking about making. Yeah, I think that's kind of a fun perspective to get, you know, from the perspective of someone, the excited perspective of someone just learning the math and physics, because a lot of people are in that position, you know, as opposed to the position of understanding it super well. You know, there's a lot of people who aren't necessarily in the position of wanting to learn it, nor are they in the position of knowing it. They're in the position of currently learning it, right? So that's kind of a neat perspective to have. Federico says, oh, I didn't know you made a video about it. Understandable, and thanks for the explanation. It made sense, and it's a challenge to explain something without drawing it. I'm glad it made some sense, and yeah, I've made 3 videos about the topic. Like I said, I sent you what I think is the best one, so glad it made sense. I think I like to think I can explain things quite clearly, but you know, it's a little tougher to do live off the top of my head when there's a lot of stuff running through my head when I do these live streams. And I could write stuff down, right? I have an interface to do that, but I, you know, out of laziness, I avoided it. And Mahesh Patel just sent a SparkNotes version of the proof. So thanks for that, Mahesh. And Zolisa says, I need to binge the channel. Well, I mean, I wouldn't mind if you did, but always be careful about passive learning, right? So videos are great. You know, I think my videos are pretty good. My explanations of the topics. I try to be super thorough in my explanations, you know, to make sure that, you know, that the big ideas are really clear, and that the important, you know, sort of sticking points of different concepts are really cleared up. I really try to focus on that in my lessons. But you know, just like how you have to pause between chapters of a math book and do some exercises if you really want to solidify the concepts, you know, gotta pause between videos or long sequences of videos to do some exercises, and you know, that's how you really get comfortable with a definition, you know, is writing some proofs about it. But I hope you will find my videos helpful. My graph theory playlist has just over 140 videos, and I think I will make maybe 300 more or so, and then the graph theory playlist will be done, roughly speaking. Juanci Garnica, or Garnisa, says, if you had to choose one, differential geometry or statistics. I really haven't studied much differential geometry, and my study with statistics has been kind of narrow. Like, I've spent a decent amount of time with statistics, but not broadly. I probably just have to, I don't know. Statistics is okay. I'd probably have to say differential geometry, because I haven't really studied it, and I would like to. And I'm not enthralled by statistics. I think it's cool. But if, like, I'm just choosing something for my personal life, let me have some differential geometry. That would be my choice. Jasu, thanks for coming by the stream, says hi, hello. Hi and hello to you, Jasu. Nice to see you here. Again, thanks everyone here for hanging out tonight. Fun to chat with you all. Drop a like if you're enjoying the stream. Always appreciate that. And I hope you're all doing well. So let's see. Let me, so I'm having ideas, you know, for some new types of content, right? I'm always brainstorming, always trying to think of what some fun things I could create for you guys. So in thinking about a particular type of content I might want to create, I'm trying to revisit some old math tricks that I used to know and other interesting math stuff. So let me show you one of these cool math things. I think I will show it to you if I can connect my tablet. If I can connect my tablet to my computer. Let me see if I can figure this out here, because I haven't done this in a while. Let's see. Frederico Schmidt says, which one was more influential, Leonhard Euler or Carl Gauss? That's a tough question. You know, those are like, I think the nicknames I've heard for those two, you know, Carl Gauss as the Prince of Mathematics, and Leonhard Euler, he definitely has a few nicknames. I think was it one of the Bernoullis, or maybe someone else described Leonhard Euler as the master of us all. I've also heard him described as analysis incarnate. Those are, you know, two of my favorite mathematicians, of course, but Euler, I like Euler a lot, just in what I've read about Euler. Like, as a person, I really like Euler. So he's my favorite of the two. He's probably my favorite mathematician. I actually have a big canvas of Euler out in my living room hanging on the wall. It's one of only two things that I have hanging up in my apartment, except for the giant pie poster behind me. But as far as which one's more influential, I mean, that's tough to say. You know, it's not like I'm familiar with everything they ever did. But I guess Euler's name is just everywhere, you know? So it's like, if I had to just give you a wild guess, I would probably say Euler. But I mean, they both did so much. Euler was far more prolific. You know, Gauss really had such a high standard of rigor, you know, and he did so much that he didn't even publish. You know, he had so many papers that he just never bothered publishing, and people would send him stuff, be like, hey, you know, Carl Gauss, the greatest mathematician in the world, look at this cool thing I did. And Gauss would be totally dismissive of it, because he had already done it, and he just hadn't published it, so nobody knew. But, so there, I think Euler, if I had to bet, I'd probably say Euler was more influential. But, you know, they're both great. So let me see if I can connect my tablet here to my computer and show you guys my screen, so I can just show you this neat little math thing. I don't know if my cord can reach. My computer's a bit of a mess right now. Let me see here. My voice is gonna get real spacey since I'm moving around in awkward directions. Oop. I just knocked over one of my hard drives. I hope that didn't disconnect it. I'm gonna destroy everything here, trying to get this working. Come on, cord. Sometimes you're just pulling a cord, you know, and it's like, you feel like you're knocking all this stuff over, you're destroying everything, just trying to get this cord out of where it is. Okay, and now I'm gonna unplug this audio thing, and now I'm gonna plug this cord. I really need more USB ports, man. This is a mess. So I'm trying to kind of get familiar with some sort of math magic kind of tricks that I used to know, and like mental arithmetic stuff. So let me show you, if I can, this trick that I saw today that I really like. Mauricio Vega, I don't think I've seen you in a while, Mauricio. Good to see you here. Says, hey, Chief, love seeing this. Glad to have you here, Mauricio, for another Math and Chill stream. This is number 26, so glad you're here. Xin Zhao says geniuses are messy people in order to be creative in their solutions. Yeah, a lot of the great geniuses were messy people. I just think of Leonard Euler. In what I've read about him, he would be later in his life, he had a bunch of kids. So, he's like partially blind and he's bobbing a kid on his lap while he's doing math. It's like, this guy's crazy. I really want kids. So that part of Leonard Euler, that he had a lot of kids, it endears me to him because I relate to that. So I need you guys to help me out, okay? I'm going to put my iPad screen where I make all the math lessons, where I make some of the math lessons, is on the screen now. I need you guys to give me two numbers between 1 and 20, okay? Give me two numbers between 1 and 20. That's what I need you to do. So I'm going to wait. Somebody, give me two numbers between 1 and 20. I'm going to make, let's see, I'm going to make 10 lines here. 1 line, 2 line, 3 lines, 4 lines, 4 lines, 5 lines, 6 lines, 7 lines, 8 lines. Yes, Joshua, they have to be integers. Give me two integers between 1 and 20. Frederico gives me 19. Someone give me another one. We've got 19. I need one more. 10 lines, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10. We don't really need these lines, but I'm going to have them there anyways. So Frederico's given us one number, the 19. I'm going to put that right there. And Xin Zhao says 14 and 6. Axel guy, we can do this a bunch, but let's see. 14, 6, if you add them together and divide by 2, you get 10. If you add 4 and 12 together and divide by 2, you get 8. I'm trying to see if there's any funny way that I can pick one of these numbers. I'll just pick I guess I'll pick 4. Axel said it first. 4 was her first number, so I'm going to pick 4. Let me see here. Jolisa says, if you don't mind me asking, what kind of work did you do in research? Jolisa, I'm not sure if you're asking what work I did in the research that I previously described, or if you're asking, like, what work do I do now in research? I'd love to do research now, but I don't have time. But the work that I was doing in research had to do with combinatorial games that were played on graphs. That's it didn't even come up. I like game theory a lot. Combinatorial game theory. That's a field of math that I like a lot. That's what my paper is in, that I've just not talked about on the channel at all. My favorite theorem is a combinatorial game theory theorem. So that's what it was. That was the field. Mahesh Patel says, I sometimes wonder why you have only 26,000 subs. I know that it's not a small number, but still you deserve more. I think that the reason is that 70% subs of any math channel is high school students, and channels like Black Pen, Red Pen covers contents like some calculus problems and that stuff which fascinates students. I always appreciate the sentiment. People say, this channel's so underrated, or it deserves more. I do appreciate the sentiment. And you're right, it's like, why only 26,000 subs? That's not a small number, so I maintain appreciation, for, it's, I'm so glad, that I've been able to reach so many people with the math lessons. And I always say happy but not satisfied, right? I'm happy that I've got 26,000 subscribers on the channel. The subscribers doesn't really matter, I'm happy that I've been able to reach over 3 million people with the math lessons, because it's the views that are kind of the important thing when it comes to teaching people math. That's kind of the important number. But the subscriber number is a nice number. But yeah, I look at the landscape of math YouTubers, and it's like, a lot of what's popular is just people doing weird calculus problems, you know? And it's like, what's with all the love with just like, for just integrals and calculus stuff? You know, that's what people like, so that's what people like, you know? It's cool, but, but yeah, you're right. So part of the reason, 70%, so the problem with a lot of math channels, we all suffer with this to varying degrees, is that a lot of our subscribers didn't subscribe because they like math. They subscribed because we help get them through their necessary evils, which, you know, is the mathematics they're working through in high school. So like, you know, that's the reason Khan Academy or my channel or other similar channels don't get like any views when we upload a new video. Relative to the number of subscribers we have, the views are super low because most of the people who have subscribed just subscribed because, you know, they found the channel useful, but at any given point they might not need it anymore, or the uploaded video might not be relevant to them. So the numbers, anyways, we're getting into boring talk about these numbers, but I appreciate your sentiment, Mahesh Patel, and I'm gonna keep working hard, and we'll hit that big 100,000 subscribers mark eventually. But if you want to help me grow, sharing the videos is always a huge help, especially sharing the more shareable videos, you know, like the math raps and stuff that anyone can kind of enjoy. So if you want to help me grow, then sharing those videos is a huge help. Mauricio Vega donated what I think is 100 Mexican dollars. I think that's what that is. So, you know, I don't know what that is in my currency. It looks like a very nice amount. Says, love your videos, Chief. Keep it up. Thanks so much, Mauricio. I really appreciate that. You know, it's the donations mean a bunch to me. You know, I work super hard to make these math videos, and it's thanks to having a career outside of this and to the donations of nice folks like yourself that I'm able to put so much time into this. So I really appreciate that, and I'm gonna keep it up for you. I'm gonna keep it up and try to help as many people as I can with these math videos. There's a lot of work left to do. I've said it on several occasions that I want to make at least 15,000 more math lessons before I stop, so I'm gonna keep going. Thanks so much for the super chat, really appreciate it. Xin Zhao says, what is your opinion on the book Proofs by Jay Cummings? So what I'm going to do is ignore you guys for just a second. I don't want to leave you hanging on this cool trick, right? I took your two numbers. Let me show you the trick. So here's the trick. The thing about this trick is it's not really cool when I'm writing the numbers down, but let me tell you sort of how this trick works. So I would tell you, I'd be the presenter showing you this trick, and I would tell you to pick two numbers, two integers between 1 and 20, just like we did, and write those, you know, on the top two lines. I wouldn't know the numbers you chose, right? So this is how the trick would work. And then I would tell you, on each line, add the previous two numbers. So for the third line, we add 19 and 24, and we get 23. For the next line, we add 23 and 4, and we get 27, and continue going in that way, right? So 27 plus 23, which gives us 50, 50 plus 27, which gives us 77, 50 plus 77, which gives us 127, 127 plus 77, which gives us 204, I believe, 204. Sorry, my handwriting's really bad. My iPad is at an awkward angle. And then, am I doing this right? Am I doing this right? Am I doing this right? I think I'm doing this right. 23, 27. Yeah, and then 127 plus 204, right? So that's 331. 331. And then 331 plus 204, which is 535, right? So you would go through this process. I haven't seen your list yet. And then I would say, okay, show me your list of numbers. and I would say, I'm going to add up those numbers like in just an instant, right? Show me your list of numbers. I'm going to add them all up, and I'm going to do it super quick. So obviously, I have not thought through what the sum of these numbers are, and I have not practiced this trick. But the sum of all these numbers, let me tell you what it is. It's 2,244. 2,000. No, it's 2,000. No, it's what is it? 2,244. I think that's what it is. That's what I'm placing my bets. The sum of all these numbers is 2,244. 2,244 is, yeah. We'll check that in just a minute, but that's what my bet is. So the trick would be, you write this list of numbers, all these numbers. I haven't seen them. You show it to me. And I mean, you could show it to me for just a second and then take it away, and I would be able to tell you what the sum of the numbers is. So you can check me with a calculator. Let me write down what my answer was. I said it's 2,244. I said that's what the sum of these numbers is. So let's check it on a calculator, see if I got it right. 19 plus 4 plus 23 plus 27 plus 50 plus 77 plus 127 plus 204 plus 331 plus 535. Wasn't even close. Wasn't even close. So like I said, I haven't practiced the trick, but it's an easy trick. I'm just not doing it right. All right. Well, forget this ever happened. This has never happened. This has never happened. Forget the trick. God. Let me see. Let's see. Zolisa says, have you done metric spaces? If yes, any book recommendations? No, I haven't really studied metric spaces. They've come up in some of the books I've studied. Well, yeah, I mean, metric spaces, right? A metric space, so like we create a metric space with the, the distance between vertices of a graph is a metric space, right? So it's, to have a proper metric, it has to fulfill a few requirements, like the triangle inequality, and it's got to be greater than or equal to 0, and a few other things. One of the books I was reading, I haven't read all of it, but I've read like half of it, is Introduction to Topology by Bert Mendelsohn, which covered metric spaces, and I thought that was really good. So I kind of remember it, but I haven't read that in a while. I don't really have to deal with metric spaces much in the math that I typically do. So for metric spaces, Bert Mendelsohn, Introduction to Topology, covers them, and I thought that was a really good, I thought it did a good job of it, but that's all I could say. I've seen it in a couple other books, but most of the focus in the books I've read was in that Intro to Topology book. That's by Bert Mendelsohn. Frederico Schmidt says, I think the reason why you are not so popular is because you center around graph theory and real analysis, which I love, but aren't as common and useful in a college test. Yeah, I think there's certainly a degree of truth to that, especially the graph theory. Like, there's really not much competition with graph theory, and it's pretty popular because there's math people who want to learn it, and there's a bunch of computer science people who want to learn it. I'm just trying to maneuver my computer here. So yeah, those are more niche subjects, but, whereas, calculus, like everyone's going into college and they're having to learn calculus and it's tough, so, I definitely want to, create some playlists for calculus, like what would traditionally be your first 3 calculus courses. But haven't gotten around to it, and obviously it's going to take a long time. And real analysis, like you say, that's also, less people are doing that, I thought my real analysis playlist would take off a little bit more quickly. You know, some of the videos are starting to gain traction, but you know, a lot of them haven't yet. I suspect they will, but I expected it to be a little bit more quick. And I wondered why. You know, why is the real analysis playlist not taking off as quick as maybe I expected? Because I thought, you know, this is going to be the best real analysis playlist on the internet, which is my hope for it. You know, I still have a ton of work to do for the real analysis playlist. But I think maybe it could just be that people who are studying real analysis, a lot of them, by the point they're studying real analysis, are experienced enough with mathematics that they really don't need that much help as they might need from someone who's, you know, in a Calc 2 class, you know, still pretty early on in their time studying math. That could be the case, or it could just be that, you know, it takes time, and it's probably, maybe it's a little bit of both, but I think, I hope that it's going to help a lot of people in the long run, and it already has, but, you know, I hope it'll grow a lot more. And only recently has my channel become, you know, sort of focused on graph theory and real analysis. You know, I didn't really upload any real analysis lessons until this year. Really, I would say my channel's focus is graph theory and set theory, speaking more, you know, with a more wide view of my channel's entire history, graph theory and set theory, really. Mauricio Vega says, OMG, 15K, that's insane. Dude, you are an hydro homie. I'm not sure what you mean by 15K, Mauricio. 15,000 what? I'm not sure. And are you making some comment about my water, hydro homie? I need a lot of water to be able to talk, like for these live streams. I'm almost losing my voice. It's already past 11, man. You guys have had me chatting all night. I haven't done much rapping at all. But it's been a lot of fun. Yeah, I drink a lot of water. Yeah, Mauricio says, I got 1,397. That's what I got too on my calculator. I see some crying, laughing emojis at how wrong I was with my addition. What did I do wrong, man? I got that so wrong. Joshua Bowden says, I'll have to... I'm too tired to find this that funny. Joshua Bowden says, I'll have to show that trick to my friends sometime. That's super funny, Joshua. That really cracks me up. Let's see. Mahesh Patel says the formula can be made by assuming the first two numbers are x and y, then continue summing, then reach the final formula. Then the sum can be found by knowing the first two numbers only. Yeah, so Mahesh, that's true. But here's how it's supposed to work, right? I did it totally wrong, but here's how it's supposed to work. Yeah, let me show you. I'll plug my iPad back in here, and I'll show you how the trick's supposed to work. Because it's slicker than that, right? It's even slicker than that. Mahesh Patel says 15,000 is the number of videos you said that you have to make. And yeah, that's what he was referencing. You're right. So yeah, Mauricio said 15,000. That's insane. There's so much math, Mauricio. So 15,000. I mean, I'm closing in on 700 videos. So and you know, I've barely scratched the surface. So we're shooting for 15,000, right? That's the goal. So let me show you my iPad again. I'm gonna plug it in here. We're gonna revisit this trick. Well, the thing is, like I said, it's not really a good trick when I'm the one writing the numbers, but maybe just to redeem myself, we will revisit this trick on a future show, just to redeem myself. I remember when I was learning some cool, getting really good at mental math back when I used to be really good at it, and I was trying to show these cool tricks to my girlfriend at the time, now ex-girlfriend. Apparently these math tricks weren't enough to keep her around, but I was like, okay, give me this, that, or the other. And, I was like, okay, this. And I got it wrong. And she was like, no, that's, I put it in my calculator. It's like, oh, it's wrong. It's like, damn it. I was like, okay, give me another number, And it's like, oh, it's wrong. It's like, oh, I got it wrong. Okay, give me another couple numbers, doing like multiplication or something quick in my head. And I got it right. And I'm like, look at the trick. Pretty cool, huh? And it's like, that's not cool. You got it wrong like 2 out of 3 times. I was like, okay, well, look, it's practice. It's hard. So that how the trick is supposed to work is, like you were saying, if we call the numbers x and y, right? We call the numbers x and y. First, we would have x, then we would have y. Then we would have x plus y. We're adding the previous 2 each time, right? So then we would have x plus y. Then we would have x plus 2y. Then we would have 2x plus 3y. Then we would have 3x plus 5y. 3x plus 5y. Then we would have 5x plus 8y. Then we would have 8x plus 13y. Then we would have 13x plus 21y. And then we would have 21x plus 34y. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 7. Yeah, clearly I don't remember how this trick is supposed to work because, yeah, I don't remember, man. What am I getting wrong? Okay, hold your horses and set this aside for now. I hope you'll be excited for a future live stream when I actually have this trick to show you and I actually know what I'm doing. I'm sorry that I totally blew it this time. I thought it was going to be cool, but I totally screwed it up, so sorry. I didn't mean to do that. I didn't mean to waste your time with my stupid trick. Let me see here. Mahesh Patel says, gotta go. I have to attend my mathematics lecture. Enjoy your lecture, Mahesh. Thanks a lot for coming by. I'm super glad that you enjoyed the stream. It was great to have you here. Mauricio Vega says, r/Hydro Homies is a subreddit of people passionate about drinking water. I consider myself one. That's such a silly subreddit. I've never heard of that subreddit. Yeah, I mean, I wouldn't say I'm passionate about drinking water, like, I like water, but I mean, I don't drink out of a jug because, I like water so much, I drink out of a jug because I'm a single dude living alone in an apartment. You think I'm going to pour this in a glass? If you think I'm going to pour this in a glass, you're crazy. In one live stream quite a while ago, someone said, "Sir, stop drinking from a jug." I was like, what? Stop drinking from a jug? Why does that bother you? Why do you care if I'm drinking from a jug? And I began to describe why I drink from a jug. I was like, look, if you have your water in a glass, then you can only drink so fast, right? You can't just swig it down, because if you do that, you're going to splash the water all over your face. I said with the water jug, though, you can cover the top completely with your mouth, right? And then swig back and you have no worries. So I said that, and then I spilled the water from the jug on my face. And it was one of the most hilarious moments of my life. It was a lot like tonight, actually. Embarrassing and just ridiculous. Jolisa says, you are funny, Wrath. I'm glad that you can at least laugh, I'm glad to entertain, even if I can't show you my cool trick. I'm glad that I can entertain you. Xin Zhao says, it's all good, man. Positive vibes, still strong with you. I appreciate that, Xin Zhao. I'll come back with 2 math tricks to show you next time. So we'll look forward to that. Jolisa says we need a sequel to The Trick. Okay, well, as far as a sequel to The Trick, like right now, a sequel to The Trick. There's a lot of cool mental math tricks, especially back when I was big into doing mental math. So I used to. This might sound like a depressing story, but it's not supposed to be. I would spend. There was a period in like high school or middle school where I would lay in my bed with my calculator on my phone. It wasn't actually a phone, it was just an iPod Touch. But I would lay in my bed practicing dividing big numbers by 9 in my head. And that was how I would that's how I would lay in bed and go to sleep. Joshua Bowden says, gonna hit the hay now, but I enjoyed the live stream. Hope to catch another one soon. I'll be live streaming again soon, Joshua. So if you see it, you'll see me again soon. And I hope you have a good night. Thanks a lot for coming. Great to have you as always. And yes, enjoy the rest of your night. I'll ask you guys, so here's my sequel to the math trick. My sequel to the math trick is a dumb math question for you, all right? I asked this question in a previous live stream, so some of you might have already heard this dumb math question, but probably a few of you haven't. So I'm gonna ask you this really dumb math question. Tell me what you think the answer is. Nobody spoil it. If you know the answer, if you know the answer, tell me. But if you already heard me give this stupid question, don't spoil it. So the question is this. We've got a ship, right? And there's a rope ladder hanging off the side of the ship. The rungs of the rope ladder are all 1 foot apart, right? They're all 1 foot apart. The very bottom rung of the ladder is 1 foot above the seawater, right? So the boat's in the water, and the bottom rung of the ladder is 1 foot above the water. All the other rungs are 1 foot above that, and so on. So the question is, after 6 hours, how many rungs of the rope ladder will be submerged in the water? That's the question. That's the very good math question. How many rungs of the rope ladder will be submerged in the water after 8 hours? They're spaced 1 foot apart, the rungs on the ladder, and the bottom rung is 1 foot above the seawater. Oh, key detail, the seawater is rising at a rate of 1 foot per hour. 1 foot per hour, the seawater is rising. And how many rungs of the ladder will be submerged in 6 hours? That is the dumb math question, which I will tell you the dumb answer in just a minute or two here. We will wrap the show up shortly as the night grows old. It's 11:18 p.m. for me right now, so I'll have to get going to bed pretty soon here. I would like to give you a sneak peek of the math song that I'm hoping to release on Monday, but I really think my voice is too worn. I don't think I can sing it for you, but I'm gonna kind of flirt with the idea. Let's see. If I go over to my instrumentals, the instrumental of the song is this. It's something like this. It's a little guitar, right? Da da da. It's great. Da 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 da's of A plus B. Da 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 da. I don't even remember the lyrics to this song. How's the song go? Can I sing this song? My voice is really worn, right? Maybe I'll try to sing you just a little bit of this song. It's a silly song. It's a different math song. How's it go? It's something like the only question left was to expand the square of A plus B. Well, that's no problem, I understand, I can do it easily. So I stare at my opponent, drop the 2 from the exponent. It's like A and B are on a picnic with sandwiches, but the sandwiches are powers of 2. I wish that you would call me back and tell the truth. I turned in my finished assignment and hoped for a grade that I was fine with. That's your sneak peek of the song. Like I said, my voice is really worn, so it's gonna sound better than that. But that's your sneak peek. It's called "The Stupid Loser." The Stupid Loser Who Forgot 2AB. It's a short song, and it's a banger. All right, I'm gonna ask you the math question one more time, and I'll tell you the answer shortly after. The question was: we got a ship in the water. There's a rope ladder hanging off of the ship. The rungs of the rope ladder are spaced 1 foot apart. The bottom rung is 1 foot above the water. Then they're all 1 foot apart. The water is rising. It's rising at a rate of 1 foot per hour. How many rungs are submerged after 6 hours? That's the question. Xin Zhao says, singing pretty good. Thank you, Xin Zhao. I appreciate that. My voice is really scratchy right now after all this talking, but makes it especially hard for me to hit the low notes. I think I can still hit the high notes okay when my voice is this worn. There are some good harmony parts in the song. Something like, what's one of the harmonies? It's, Mauricio Vega says, that's pretty good. Thank you, Mauricio. There's some harmonies I really like. In fact, some of the harmonies are more in my head than the original vocal part of the song. Let me just play the instrumental again, see if I can remember. Oh, wait a minute. Did I have my desktop audio muted? Did I just sing for you guys a cappella with no instrumental? That's embarrassing if I did, because I didn't mean to do that. Let me know. Did I sing a cappella? There was supposed to be an instrumental, but I might have had my instrumental muted. Again, let me know if you think you know the answer to the math question, and I will tell you the answer shortly. Some of the harmonies in that math song are they're a little in the higher register, kind of tough to sing. Like there's something like the square of A plus B. Easily. So I stare at my opponent, drop the 2 from the exponent. Oh no, I think it makes it even harder for me to hit the high notes when my when my voice is worn. I don't even remember the harmonies. Xin Zhao says, I'm usually thinking about a whole world of math whenever I listen to the Game of Thrones theme. It's amazing you were able to create songs and raps around math. I've wanted to read Game of Thrones because I've been trying to read a little fantasy recently because I haven't read much fantasy in a long time. I'm not super into like shows, but Game of Thrones, I bet, has some fantastic music. I am glad that creating the songs and raps around math, I'm glad that you get a kick out of it, Xin Zhao. It's a lot of fun for me to do. I like making music and stuff. So, it's fun to combine the two. And it definitely, I wouldn't say it's something that, like, I think, like I said, writing music and lyrics and stuff is something I do. It's something I've been doing a long time. Writing raps, I've been writing raps ever since I was in middle school. So, like, when I'm writing a math rap, it's not me just combining math and rap because I think it's funny. It's two things that I've done a lot. So I think I like to think they're okay. Mauricio Vega says, yes, you did sing a cappella. Yeah, that's not what I meant to do. Let me do it one more time with the instrumental. All right, I'm just gonna sing it again with the instrumental, the way it was supposed to be. Again, apologies for my rough voice, but I'm just having fun here, So let me take a sip of water and I'll sing just a piece of the song with the instrumental. Actually, you know what? We'll keep it a sneak peek, right? So you just get the a cappella. You don't even get the instrumental. So super sneak peek, right? Half of the song is missing. You don't have the instrumental. You don't have the vocal harmonies. That's how we'll do it. I think it's a good song. The finished version, I really like. I'm really bopping. It's like an emo math song. I like it a lot. So, all right. So, what I'm gonna do, is tell you the answer to the math question. The answer to the math question, uh, the question being, we've got a rope ladder hanging over a ship. The rungs are spaced 1 foot apart. The bottom rung is 1 foot above the water. The water's rising at a rate of 1 foot per hour. After 6 hours, 0 rungs of the ladder are submerged in water, because as the water rises, so does the ship. So, so none of the ladder is submerged because it's all going up with the water, and that is the dumb math question that that I'm keeping in my back pocket because I find it amusing with how stupid it is. But I think we'll call it a night there, folks. It's been a lot of fun. Thanks a lot for coming. It was a busier stream than I expected, so it's always fun to have that. Lots of good chatting tonight, and I'll see you again soon. Next stream might be this weekend. If not, it'll be early next week. But we'll see. New video comes out tonight at midnight in 30 minutes. I don't know what the video is. I've got a couple, maybe it'll be a video on Kruskal's algorithm, I think, graph theory video. So that'll come out in 30 minutes. Check that out if you're interested. Shinjiao says, haha, good night. Good night. I'm glad that you found that question amusing. And I want to say, again, a big thanks to Mauricio Vega for the super chat donation. Really appreciate that. If you guys want to help support the channel, the donations are always appreciated. There are donations